or is there a better way to write it? And I don't see any way to rewrite this one. The second thing I ask myself is, what's like the derivative down here? It's 2x. That's not what I have on top, right? So it's not a simple u substitution. It's not a partial fraction. I don't know how to long divide things that have square roots in them. So I'm definitely looking to apply some technique here. But I do see two possible ways to go about this. So let's talk about both of them. One is, well, the derivative of the bottom is 2x, right? In a sense, there's an x up there. I just have to separate it out. If I take x squared times x over the square root of x squared plus 9 dx, what does that look like might possibly work? What technique might possibly work on that?
U substitution.
Well, a u sub works on this half, right? What happens if I take the derivative of this? It gets simpler, right? What happens if I take the antiderivative of this? It gets simpler, because the antiderivative of that
Integrated by parts.
So going back to my integral of u dv is uv minus the integral of v du. If we let u be x squared and dv be x over the square root of x squared plus 9 dx, and du is simple, and v is x squared plus 9 to the 1/2. Because derivative of this is 1/2 of this to the minus 1/2, that's what puts it in the denominator, times the derivative of the inside, which is 2x. 2 cancels with a half, and I get that back. With me? Tyron, you look worried. You good? Okay, so this is the product of two things, one of which when I integrate it gets simpler, and one of which when I differentiate it gets simpler. Well, that's integration by parts. That's how you know to use integration by parts. So that thing becomes uv x squared plus 9 to the 1/2 minus the integral of v du, which is 2x over, which is 2x x squared plus 9 to the 1/2 dx. Hey, the derivative of the inside is right here. So that's an easy integral, right? It was Andrea who asked a really good question. She's really good at asking a really good question and not being in class next time to hear the answer. It's 3 times in 2 semesters. So, I hate to erase all that nice work. So long to do and so fast to wipe out. Okay, so that's one way. Another way is to say, what's the Pythagorean identity? It looks kind of like x squared plus 1. Well, tan squared plus 1 is secant squared. So I'm going to let x be 3 tan of whatever you want. I'll call it theta. It's an acronym. So if x is 3 tan theta, then dx is, derivative of tangent is secant squared, 3 secant squared theta d theta. And I've got x cubed. X cubed is 3 times 3 times 3 is 27 tan cubed theta over square root of 9 tan squared theta plus 9. And then dx is 3 secant squared theta d theta. Be sure you're with me there. Yes, sir.
Where did 27 come from again?
I hope that I cubed x. If you cube this side, I've got to cube this side.
Okay.
And 3 cubed is 27, and 10 cubed is 10 cubed. I'm just cubing both sides to get that. That looks a lot worse than what we started with. Yeah.
Why'd you write the 3 secant squared?
Because dx is the derivative of this, and the derivative of tangent theta is secant squared theta. So it's 3 secant squared theta d theta. So I just, that whole thing is my dx. That whole thing is my x cubed. That whole thing is substituting 3 tan theta in for x. Because 3 tan theta squared is 9 tan squared theta. Everybody good on where I am so far? The hard part is done. Okay. So now I just have to simplify the bottom. And Andrew explained this really well in class, but the best thing is to just write it out. Factor a 9 out. Check your trig identity. Sine squared plus cos squared is 1, to be sure I didn't screw up. Divide by cos squared, that's tan squared. Divide by cos squared, that's 1. Divide by cos squared, that's secant squared. So I didn't screw up. That thing's secant squared. 9 secant squared theta. And why is that a lie? Right? The square root of something squared is the absolute value of it, right? So really, there's an absolute value down here. Well, what can I tell you? This is one of those times in life where you can get away with a lie. Remember that at the end, what matters is that if we take the derivative of what we get this back. Well, you will. So even though I don't want you to forget that the square root of x squared is the absolute value of x, this is one of those times where you can just say, well, let's suppose for the moment secant theta is positive, and keep working. Okay, so this whole thing becomes 27 tan cubed theta over 3 secant theta times 3 secant squared theta d theta. That cancels with that. One of these cancels, and I take the 27 outside. I've got a tan cubed secant. Now I'm hoping that's an easy one to do. Let's see. The derivative of tangent is secant squared. Darn, I don't have a secant squared. The derivative of secant is secant tan, so I've got to do something with this, right? Well, if I take a tan squared out and turn it into secant squared, then I'll have one tangent left, won't I, to have a secant tan. So I'm going to try that. I'm going to say that's tan squared theta, tan theta, secant theta, d theta. And that's 27. Now what was that tan squared? That tan squared was secant squared minus 1. And then I'll reverse the end. So that looks like du, right? When I let u be secant squared. So that's 27 times parentheses the integral of secant squared theta times secant theta. Well, let's do the So u is secant squared theta minus 1. du is two secant theta. Oops. No, I don't like it. I'm sorry. I don't like it that way. I'm going to do it my way. Equals 27 integral of secant squared theta times secant theta tangent theta, d theta, minus 27 times the integral of secant theta tangent theta, d theta. Secant squared, just multiply it out. Negative 1, multiply it out. We good? Okay. 27 1/3 secant cubed theta minus 27 secant theta plus k. 1/3 secant cubed, 1/3 times this is secant squared times root of secant, which is secant tan. Their secant is secant tan.
On the second line on that one, could you just put u sub and let u be secant?
Yes, absolutely. And then du is secant tan. I started doing u sub, and then I wanted u to be secant squared, and I hate u subs. They always mess me up. I'm better at guessing antiderivatives than I am at u sub. So I just decided to show it a different way. You're absolutely right. We've been seeing lots of u subs, so I just thought I'd show you a different way. But it's right. Yes. What you got, Gerardo?
From the next class, then
Okay. I know, I'm doing a u sub in my head, except that I don't do u subs. I know the derivative of secant is secant tan, right? So the derivative of secant is secant tan, so I just guessed the antiderivative. 1/3 secant cubed, you think of it like this. What's the derivative of that? If z is 1/3 secant of theta cubed, then z prime is 1/3 times 3 times secant of theta squared times the derivative of the inside, which is secant theta tangent theta, right? Well, those cancel, and that's what I have. So I just did the antiderivative in my head. Tyron said, well, didn't you just let u be secant theta? Which is the same thing. And you could have done that right here. I started to pick the wrong u. I started to pick u as secant squared, and that made things ugly for me, and I don't like u subs because I always guess the wrong u, as demonstrated just now. So I just guess the antiderivatives. Much makes me happier. Yes?
did you just distribute that 27 throughout the...
Yeah, I've got 27 times the whole thing, so if I decide to break this into two integrals, that 27's got to hit both of them, right?
Right.
And so in the end, I have 9 times this one minus 27 times that one. All right. So I just want to show you there's two ways to do this one. Integration by part, it looks like a natural trigonometric substitution. But trig sub is a lot harder than integration by parts.
This one done over here?
Pardon?
This one over here done? The first
Well,
one?
I didn't differentiate this, but I could have, I think. Add 1 to a half, get 3 halves. I'm going to end up with a 2/3 out front. And I've got a 2 out front. Is that it? This times this is 1 times x squared plus 9 to the 1/2 times the root of the inside, which is 2x. So it's done now.
On your DVV, shouldn't there be a 2 out in front of the B part? Like, how did you do the?
Let's see. You don't trust my B? Is that what you're telling me?
I was trying to do.
Oh, believe me, I make mistakes all the time. Let's check it. If V is x squared plus 9, I did it all in my head, which is dangerous. Right? Did I take the derivative of that correctly? 1/2 out front, this, subtract 1, multiply by the derivative of the inside. Those two cancel, right? This moves to the bottom. That's it. But keep asking, because I make mistakes all the time. They're still laughing at me from trying to multiply last semester.
I've got a question over here.
Yep.
Between the second and third steps, you lost me.
Here to here?
Yes.
Algebra. I distributed this. Secant times secant squared is secant.
Cubed, right?
Oh, I threw one away. No, whoa. Back the track up. No, I didn't throw anything away. I multiplied this whole thing by this. So secant squared secant theta, and then -1 times secant theta. And then I distributed the 27. Yeah, I didn't want to multiply that through. I pulled the secant tan out for good reason. It's the derivative of secant squared. Okay? All right. Let's do another nasty one.